Thank you. Good morning. What a wonderful works in this week. So I hope you can enjoy mine. So let's start. I am Isaac NAVA-BRAVO, and my work is organic waste from nixtamalization as a feedstock for the hydrothermal liquefaction process. First, different ways to produce clean energy and bioproducts from waste is on research. What I mean with that? According to the International Energy Agency, 80% of our energy comes from the fossil resource. I mean, 21 for gas, 29 coal, but petroleum is so exposed. Well, we have more energy from petroleum, 32%. From this 32%, 49% is using for the public transport. Yeah? So as the population is increasing in the world wide, we have more exhaustion of this petroleum oil and more carbon dioxide emission in the world. So we need to change this paradigm or this idea or change a different style of life, and we can use, for example, clean energy. Biomass is a good option because from biomass we can produce ethanol, biogas, biodiesel, biojet fuel, and so on. In this case, in Mexico, the corn flour industry is an important supplement in the Mexican diet. Yes, the Mexican, we love the corn, principal tortillas, no? But the economic activity from the flour industry, 3 million tons per year, is producing corn flour, but for 600 tons, we are producing 1,500 wastewater. This wastewater is called like Nejayote. And Nejayote is my feedstock for this process that I am working. But before to use a corn, we need a process. The name of this process is nixtamalization. Well, I don't know what is the pronunciation, the nixtamalization, but because in Mexico it's nixtamalización. Nixtamalization is this in the figure 1, where we use hot water and, whoa. What happened? Sorry. And okay. Nixtamalization or nixtamalización is using hot water, calcium hydroxide to change the properties of the corn before to be transformed to mass for tortillas or flour. But this wastewater, as you can see in the figure 1, is the Nejayote. This wastewater has high pH, for example, 11, high oxygen demand, chemical oxygen demand, close to 25,000 milligrams per liter. And so this is a problem because sometimes this wastewater is put in the sewage. So this is a good choice as a feedstock for hydrothermal liquefaction. What is the hydrothermal liquefaction? Hydrothermal liquefaction is, or HTL, is a process at high temperature from 250 to 374 Celsius degree, high pressures for 22 megapascals, and we can use catalyst or no catalyst. So from this process, we can change the properties of biomass and produce bio-crude. This is like a petroleum clean or artificial petroleum because it has close properties like the petroleum conventional, this bio-crude. And we can produce biochar. Sometimes it's called like the solid waste, solid residues. And aqueous waste because in this process we use water for transform this biomass. In this water or wastewater from the HTL process, we can see some hydrocarbons dissolved in this water, so can be used for other kind of products. What kind of hydrocarbons we can see in this wastewater? Ketones, alcohols, aldehydes, and so on. And gas is produced, gas sometimes has hydrogen, methane gas, methane gas, but in low proportion, and high proportion is carbon dioxide. For the special reactions, depend on the biomass. So, as alternative for Nejayote, or this wastewater from nixtamalization, we can use hydrothermal liquefaction because to our knowledge, there is no research about using Nejayote for this process. So the methodology is first, we take the Nejayote where it was neutralized and then dry up. We use a characterization like cellulose, lignin, total solid volatiles, and so on. We need to neutralize before the Nejayote because, do you remember, 11 pH is so high for a reactor, no? So we can spoil the reactor. The reactor is like the picture. We used one temperature, 250 Celsius degrees, two different kinds of total solids, 10 and 20% the total solids, two different times of reactions, 0 and 15 minutes. After the reaction, we take the mix or the mixed reaction, we put it in a beaker, and we use the solvent. This solvent is dichloromethane and ketone to recover this bio-crude using this vacuum system. So this bio-crude is analyzed using chromatographic gases with masa detector using librarinist to identification of the whole hydrocarbons in this biopetroleum. Monitoring hydrocarbon, we use flame ionicity detector. If for the biochar or the solid waste, we use the method BET to measure the specific area, diameter, and volume. For how we can use this depend on these characteristics of the biochar. So as a result, according to the characterization, there are a lot of works using corn stubborn for bio-crude production using hydrothermal liquefaction, but no Nejayote. So this is the intention. The table one to compare what happened with the content, some compounds from corn stubborn. Well, cellulose, lignin, they were lower in comparison with corn stubborn. Commonly, the bio-crude come from, in this case, the lignocellulosic biomass, come from the cellulose and hemicellulose. High content, the hemicellulose or cellulose is good to produce high bio-crude yield. So in this case, cellulose was lower, but we had hemicellulose close or a little bit or double with respect to corn stubborn. Volatile solids, this is organic material that we can use to transform, is close to the corn stubborn according to the literature. And the elemental analyze, carbon, hydrogen, nitrogen, oxygen is close to Nejayote with corn stubborn. According to literature, corn stubborn, when it's transformed with HTL process, the bio-crude yield is between the 7 to 30% of yields. But in our case, using Nejayote, bio-crude yield was between 4 to 6%. The bio-crude yield, yes, was lower in comparison with literature. But for example, Tian, they produced 7.9% of bio-crude using corn stubborn and high temperature. So this is not so bad. And first, because we are using a new material or feedstock for the HTL process. We thought that this low bio-crude yield was because we have high ash content. According to literature, biomass with high ash content, the bio-crude oil is going to be low. So this is, we can explain why we have this bio-crude yield. According to the analysis using the chromatographic gas, we have different hydrocarbons. For example, eicosene, octodecane, can be used as a precursor for diesel or gasoline, or the other kind of hydrocarbons like phenols or derivative phenols or some ketones can be used for chemical industry. And according to the flame ionicity detector figure 4, as more temperature used in this reaction, some hydrocarbons like this is going to be disappear or break up or cracking out with the temperature, and probably they went to the gas phase or the water phase. We have here pictures. This is the wastewater from the HTL process of Nejayote. This is our bio-crude, but in solvent dichloromethane, and this is bio-crude without solvent dichloromethane. And with respect to the biochar or the solid waste, the specific surface area, average pore diameter, and total volume, They are close to reporting according to literature, using biomass, any kind of biomass. And according to UPAC classification, we had mesopores from 2 to 5 nanometers, in this case for the, well, so the average pore diameter. So possible applications using this, we can use it for example, absorption of methylene blue, because this molecule is accessible to the pore larger than 1.5 nanometers. Other possible use from this biochar or resid solid is a catalyst for improvement Bio-crude. This is a new way that I can see for literature. So as conclusion, well, Bio-crude can be produced using Nejayote. Available products were obtained from like phenol derivatives, ketone, aliphatics, and so on. Biochar produced from Nejayote has the potential to be used as a solvent for wastewater treatment. In general, less total solids concentration, less time is the best condition to get more Bio-crude yield. So knowledge for the honesty, my scholarship come from, and the other schools, and thank you for your attention.